Okay, so this is the second part of the video on solving exponential equations. The phone decided to stop recording there for a moment. Okay, so our solutions for y are y equals 3 and y equals 1. And it's just important at this stage to realise that the question asked us to solve for x. So I've solved for y, but I'm not quite there yet. Now, I can relate the y that I've got here, though, back to x, because if you recall, we said that y was 3 to the power of x. So I'm going to take both of these answers and I'm going to replace the y with 3 to the power of x. And now I've got two mini equations where I need to just solve for x. I will have to do the same as before, though. I'll need to get the same base on each side, and I'll need to make sure that I've got powers and that I've followed any rules that are necessary. There's very little to do in this case. 3 here can be just written as 3 to the power of 1. And I can solve that no problem, because I can just cross off my 3's and I get x equals 1. So that's one of my solutions for x. In the other equation, I can change that 1. I can write that 1 as 3 to the power of what? Well, again, looking through my rules, 1 is any base to the power of 0. So I can write the 1 as 3 to the power of 0. And again, then I'll just cross off my bases. My solution there is x equals 0. And so my two solutions for x are x equals 1 and x equals 0, job done. It's very important with a question like this where I have substitution not to kind of get lulled into a false sense of being finished at the y equals stage, and to make sure to proceed as far as the solution for x. A lot of the time with a question like this also, they will actually give us the suggestion for substitution. So you may see in the question, let 3 to the power of x equals y, for example. But you have to keep your eyes open because you aren't guaranteed to get this hint. And it's important that you're able to recognise this type of question. Bear in mind, with a question of this type, you will often, not always, but you'll often have 3 terms. And that can be a hint also towards the quadratic approach. Okay, here's example 5. And example 5 is similar in a way to example 4 in that we're going to end up with a quadratic, but there's just a few other things we have to watch out for along the way. So it tells us to solve for x. So that's the first thing we have to watch out. We're not finished until we have a value for x. Okay, so we've got 3 to the power of 2x plus 1 plus 8 times 3 to the power of x minus 3 equals 0. Now, like I said, this is a substitution question like example 4. In some cases, you might be instructed as to what to use for substitution, but I'm not going to tell you just yet what the substitution term should be. Have a look, though, and see, can you figure out maybe what it might be in this case? It should be reasonably obvious. So it's the 3 to the power of x. And again, it's that middle term is going to help me make that decision. Okay, so let's have a look. That's okay, I can replace that with y. This looks a little bit clunky. So how am I going to deal with this? Well, what I'm going to do is I'm going to look at the rules of indices from page 21 of the log tables, these guys down the side, and I'm going to see, can I use those to split this term up into kind of more manageable chunks, if you like. So the first thing that I notice is that I'm adding 2 powers in that first term. And if I'm adding powers, I can reference rule 1. And adding powers means that I can multiply a base by a base, and it's the powers p and q that I have from the addition on the right-hand side of the equation. So I'm going to split this guy up into 3 to the power of 2x times 3 to the power of 1. Okay, and then I'm going to look at this 3 to the power of 2x like we did in example 4, and notice that I've got 2 powers multiplying together, so I'm referencing rule 3 here. So multiplying the powers, I can split them up and put one of them outside a bracket. So I'm going to change this then into 3 to the power of x to the power of 2. Okay, and now I'm going to do my substitution. So now wherever I see a 3 to the power of x, I'm going to replace it with a y. So what's that going to leave me with? Okay, it's starting to look like a quadratic. It's a bit messy still. I'm going to tidy it up a little bit more. Okay, so now I've got 3y squared plus 8y minus 3 equals to 0. Okay, it's a quadratic. I have to factorize and solve it. Pause the video yourself at this point and then see if you can do this, and then play and check if you're right. So we get 3y minus 1 times y plus 3 equals to 0. So I have to solve now for y. So let each factor equal to 0. And I get 2 solutions for y. So y is equal to 1/3 or y equals to minus 3. At this stage, I'm going to go back here to my substitution and replace the y with the 3 to the power of x. On the left-hand side, I'm going to take the 1/3, and since 3 on the bottom there in the denominator is 3 to the power of 1, I'm going to be able to rewrite this right-hand side as 3 to the power of minus 1, cross off the 3's, and get a result of x equals minus 1. Now, In the second potential solution, y equals minus 3 is fine as a solution for y. But when I go back to my substitution for 3 to the power of x, I run into a problem. So notice here that my base number is positive. Well, at its most basic, exponents is about, and this is at its really most basic, it's about multiplying bases together. So for example, if I square something, I multiply it by itself. If I put something to the power of 5, I multiply it by itself 5 times. If I start off with a positive value, no matter how many times I multiply it together, I can't end up with a negative result. So if I've got a positive base, I can't get a negative answer. So this solution actually has to be abandoned. It's just not going to work because 3 to the power of x cannot be equal to minus 3. So I'm eliminating that as a potential solution, and I'm giving a reason. I've got a positive base and that cannot give me a negative result. So that's gone. Bear in mind, I'm not saying that you can't have a negative value for x. I'm not saying that you can't have a negative exponent. I'm saying that when you start off with a starting point of a positive base, you can't end up with a negative number as a result once you've applied the exponent. Okay, here's our last example, example 6. And again, it's a substitution question. And again, I'm not going to tell you what the substitution is. I want you to take a moment to see can you figure it out yourself. So here's my equation. Now it's a little bit different from before because I've got a negative on my exponent in one of the terms. So what do you think I should use for substitution? Well, this time I'm going to use the 2 to the power of x for substitution. So your first port of call would be the middle term. If it's got a minus on it, go and have a look elsewhere because I generally want to substitute for a term that has a positive exponent. So this time I'm going to say let y equals 2 to the power of x. So where am I going to end up with that? Well, 2 to the power of x, I'll be able to simply replace with y, that's fine. 2 to the minus x, I'll need to do something with that first. So I'm actually going to just hold off on the substitution for a moment until I sort out what's going on with this. So I'm not really loving the 2 to the power of minus x, and I want to think, is there a different way that I could write this? And of course, the sensible place to go looking to figure that out is your log tables, page 21. So you look down through your list of rules for indices and you see, is there an option for you? Okay, so which rule looks like it might be the applicable one? Negative power. So it's rule 5, isn't it? Because it's a to the power of minus p. So here I've got 2 to the power of minus x. So how can I write that? I can write that as 1 over 2 to the power of x. Okay, so now I can go and I can substitute in that y. Okay, so at this stage, it looks a little bit like a quadratic because it has 3 terms and there's y's in it. But it's not quite the way I'd like it to look. So I need to see, can I figure out what to do with it? I'm looking at this 1 over y in particular. I mean, how am I supposed to factorize a quadratic that contains that? I'd really prefer if that 1 over y wasn't there. And I can actually sort that out by just taking the whole equation and multiplying it by y. Just to point out, this is meant to indicate multiplying by y, not xy. So I'm multiplying by y. So I end up with y squared plus 4 times y over y minus 5y equals 0. And of course, this y over y, they just cancel out to give 1 if you like. And I end up with something a bit closer to the quadratic that I want. A little bit of rearranging again. And now I've got something that I like the look of, y squared minus 5y plus 4 equals 0. So I want to factorize this now. So again, pause the video while you do that. And I get y minus 4 times y minus 1 equals 0. And then I want to solve on each side there. And I end up with y equals 4 and y equals 1. But remember, I'm not done until I solve for x. So I have to go back to my substitution again, the let y equals 2 to the x, and replace these y's. So where I have y, I need to put back in my 2 to the power of x. No problems with signs in this example because you can see that I've got positive bases and I've got positive results. So that's totally fine. I just need to focus now on getting the same base on each side so that I can solve for x. Well, 4 is clearly 2 squared. I can cross out my bases now and my solution is x equals 2. For the other solution, well, 1 is going to be, okay, let's have a look, 1 power of 0. So I can write that as 2 to the power of 0 and then cross off my bases and I get x equals 0 as my solution. So my two answers in this case are x equals 2 and x equals 0.